Hello all, here is a simple circuit which is called a sample and hold circuit. Uh, so this circuit is used in analog to digital converters where the analog signal that is input is sampled at a specific frequency, and then the sampling frequency is fed to the digital section. So because in reality, in nature, we have analog values as the sensor values, right? uh, they'll be continuously varying. Example, if you take a temperature would be continuously varying, so the temperature sensor output will always be an analog signal. It will not be a digital signal like how we have 0 and 1. It's analog signal, right? So this analog signal, if you want to read from a microcontroller, you cannot fed that directly and read it, right? That analog signal need to be converted to a digital signal first, and then um, it need to be processed further by the microcontroller. So internally, when you are giving this analog signal to a microcontroller, you will have something called a sample and hold circuit. So what it means is you are trying to sample the input, and then that particular sampling what you are doing is held at that specific value. So to sample, definitely you need some switch kind of thing, right? And to hold, you need something called a capacitor kind. So those are the key components which form part of the sample and hold circuit. And if you see here, that's what it is used. There is a N channel. So this is for representative purpose, just to understand the circuit. These are being used, which are available in the tool. So you have to use a MOSFET based on your requirement, or you can look into the different sample and hold model circuits to see the MOSFETs that are used. So one important thing definitely we can say is that this particular MOSFET should have a very low RDS on, because it is used in series. Any signal that we are inputting should not be uh, dropping in voltage, because we need to exactly get the voltage, because otherwise, example, if you want to read a temperature of 35 degrees centigrade, you might read 33 or 32 because you have read a lower value using the circuit. So it's a very important point, and definitely sometimes the resolution that you need, that means the variation from the given voltage is very critical in analog readings, right? So considering all these scenarios, this MOSFET should have very low resistance, and then this MOSFET to sample, we will be giving some pulse so that it turns on and off, and when it is off, the when it is on, basically the capacitor gets charged, and when it is off, the capacitor holds its value, because you have a voltage follower after this capacitor. You don't have the load directly connected. This 1K whatever we are representing here is a load. So you have a voltage follower here. Voltage follower has high input impedance and low output impedance, right? So considering that it has a very high input impedance, the current drawn from this capacitor to this non-inverting terminal of this op amp is very, very less, right? So under that scenario, this capacitor holds its value, and as this is a voltage follower, the output will be same as the input. That means that voltage that is held across this capacitor. So this particular voltage follower here helps us to maintain that capacitor voltage and not load the capacitor. And another important design criteria here is to what switching frequency should you switch this MOSFET. That means at what frequency you need to sample the input, because sampling is done by the switching, right? So considering the Nyquist rate, where Nyquist criteria, where it says to exactly reproduce a signal, you need the sampling to be done such that sampling rate is greater than or equal to 2 into input frequency. Okay, so considering that criteria, so the switching frequency should be selected such that it is greater than or equal to 2 FM. Higher, the better. But again, you cannot go as high as possible, right? We have to see the switching characteristic of the MOSFET at what maximum frequency you can switch this MOSFET. So another important point we have to see is generally when you see these analog inputs, right, you don't see them varying at a very high frequency. Generally, the analog inputs vary at a lower frequencies, unless we want to capture each and every input sample at a very, very high frequency. You don't need to have that much switching frequencies. So again, while selecting a MOSFET, the maximum frequency at which it can switch is also an important criteria. And continuing the discussion here, so this capacity that we are talking here should hold the value, right? The voltage should be held at that specific value, and it should not discharge, as we were mentioning. So anyway, that voltage follower is helping us, but the capacitor leakage current should be as low as possible so that the voltage doesn't drop as long as the MOSFET is off. So for that, we need a capacitor which has a very low leakage current. So in that cases, the film capacitors or the ceramic COG capacitors are the preferred capacitors here. And then definitely the operating voltage of these particular op amps that we connect here, we have connected 5 volts here, should be such that it should allow the required input voltage. So that's one of the important. And these two are just the decoupling caps for this particular op amps. So op amp again, we have used as a representative purpose here. And then we mentioned 1K is the load, the actual load to which it is connected further in down the circuit, and this is the analog input that we have connected here to this particular op amp. Again, this op amp is again helps us maintain that voltage, and it doesn't load the source and vary its characteristics. So for that, we have used a voltage follower here, because any sudden switching and load that comes onto this, the capacitor load shouldn't change the characteristics of this particular sensor that is connected. So definitely analog sensor, right? So that's how the simple circuit functions. So again, based on the different problems associated, there will be changes. This is the basic functionality of the sample and hold circuit, and every microcontroller that we talk, where we talk about the ADCs, hash must have this sample and hold circuit, because this is what, as we said, converts to a particular value, which is a digital value rather than a continuous value, right? So and then this will be further input to resistors, and the resistors store the value. We do process the value using our coding, or use different algorithms to process it and come up with the final analog value that is input. So a very important circuit for embedded engineers, which can be played around, improved further, but a very basic circuit. Thanks for watching this video. Please like our video. Please subscribe our channel, and please encourage us. Thank you.